On we go with our inequalities. You can see these are the notes for graphing compound inequalities, and basically we will be graphing two inequalities on the same number line. Okay, so you see the word or in between these two examples. So you're really just going to solve the one on the left, solve the one on the right, and then go graph them both on the number line. So for number one, they are both one step to solve. If I want to get x by itself and it's being divided, then I will multiply to cancel that denominator. That cancels that 4. I'll multiply 4 over here. And this one says 12 is less than x, or x is greater than 12. And I know this is a little bit blurry. I spent 5 minutes trying to get that better before starting this video, and there's nothing I can do. So on this one, we'll multiply by 2. And I hand wrote this example because there's one like this on the assignment. So you go over to your number line. Now you see the number line has to fit the numbers from 2 to 12. This number line is not big enough to do that, so I'm not going to count by ones. I'm going to count by twos. So I'm going to put 2 down here and count up by twos, and it fits. So you might have to get a little creative on the assignment. You might have to count by whatever you have to count by to make both of the numbers fit. Now, if I look at these as two separate problems, this one says x is greater than 12. Okay, remember, you can read these left to right. Well, x is greater than 12 is an open circle, and I graph to the right. This one says all numbers less than 2. That would look like so. All the OR problems that we work on, 99% of them will look like this. So I have two arrows that run away from each other. Okay, so what we're really graphing is all numbers greater than 12 or all numbers less than 2. That's what the graph shows. So again, when you have a compound inequality with the word or, all you're going to do is solve the one on the left, solve the one on the right, and go graph them. So looking at something like this, that should look pretty simple. For all the solving we have done, subtract 7 on both sides. That's going to be 36. And you can see x is less than 4. Or, and we'll go solve the one on the right, plus 1. 11x is greater than 66. Divide by 11. X is greater than 6. So your number line, we can conveniently count by ones on this one. 4, 5, 6. And all numbers less than 4. Or all numbers greater than 6. So open circles, and there you go. That's a typical OR problem. They're generally not too difficult. Now, I have 3 more examples. This looks a little different. This is actually an AND problem. They will graph in between two numbers. Now, it doesn't say the word AND, but that's what these are. Now, this looks a lot different than anything we've ever solved. Okay, we have 2 symbols in the same problem. That's different than up here. There's a word OR between them. Okay, some people confuse the two. These are very different setups. So what I'm going to do is, I want x all alone in the middle. So if you focus in the middle, you can see I want to add 1, then divide by 2. Well, I'm not just going to add 1 here. I'm going to add 1 on the right and on the left. Okay, we've never solved anything that looks like this. So I'm just going to continue. That's a 14. And this is a 20. Now divide by 2, but I divide by 2 everywhere. I get 7 is less than or equal to x, less than or equal to 10. Now, on the number line, something a little different is going to happen. I want all numbers greater than or equal to 7 and all numbers less than or equal to 10. That's just the numbers in between 7 and 10, including 7 and 10. See the difference? OR problems generally look like this, and problems generally look like that. Okay, 2 more, just to show you again, ones that are very similar to the assignment. These are all the same as far as the setup goes. This is just one step To get x by itself in the middle, minus 6, minus 6, minus 6. This will be a 5. This will be a 20. Now again, 5 to 20, it would make sense to count by 5s over here. And it looks like they're both closed circles. And I'm shading all the numbers between 5 and 20, including 5 and 20. And last one, I think there are 2 or 3 like this on the assignment. Another and problem. This is also one step. Divide by 5. That will be a 2. And that will be a 6. That should fit just fine over here. And these are going to be open circles. I didn't mean to do that. Oops. Pretend that didn't happen. I'm not going to change the video. That's a 2. That's a 6. Graph in between. Okay? Ignore that blob. So let me show you the assignment. So these are and problems. Okay, there's one step. You're going to divide by 2 in 3 places. You're going to subtract 3. Again, one step. You're just dividing. You'll move pretty quickly through this. This looks like the first example I did. Okay, here's an OR problem. These are one step to solve. Add 2, minus 5, minus 5. Okay, you have an and problem, a one-step OR problem. Okay, this assignment is not very long. And as always, if you need help, let me know.